Greetings from Allora Labs. Today we're going to be talking about the Allora Forge Builder Kit, which was newly released to help people get involved in our Allora Forge competitions. So in this notebook, we're going to be learning how to load training and validation data, load a light GBM model, train the model, evaluate the model on some validation data, package a predict function into a pickle file, and then run a worker node. That takes this pickle file and delivers inferences to Allora's network in real time. One thing you're going to need is an Allora data API key, which you can get by following this link and registering and creating your free key. So let's go. The first thing we're going to want to do is install the necessary packages. Yeah, one thing, I'm going to be running this from scratch, just like you would be. So we're going to see how easy it is to get up and running, doing some machine learning for the Forge. Installing can take just a few seconds, but I don't think it should take all that long. All right, looks like that's done. Then we're going to just import all the packages that we're going to need for building models. All right, the imports went through. This section, this is where we provide our API key, which I've already copied. I'm going to paste it in, hit enter, and we don't want to save that. So the first thing we're going to do is initialize our workflow. In this example, we're going to predict on Bitcoin. We're also going to use Bitcoin for the training data. This corresponds to a new free topic that we have, so that's what this example is going to handle. So here we have 3 parameters that go into the Allora workflow that help define the training data and also the target that we're looking to predict. So the first parameter is called hours needed, and this is the length of the look back window that we're going to use to make the features. So in this case, I want 5 times 24, so that's 5 days of look back. And then the next variable here is the number of input candles, which I want to set to 12. So it's going to divide those 5 days up into 12 candles that I'm going to use as input data. And the target length here is 24, so that's like a 1 day in the future target, and that corresponds to the target of the Allora Forge topic. So different topics have different targets. For example, now there's one that's 8 hours prediction on Bitcoin. So here you'd want to change this to 8. But right now we're going to go for the 24-hour prediction horizon. So that is quick. There's nothing really happening there. Once we've defined our workflow, we can now start doing some machine learning. And the first thing we're going to want is data. And so those variables that we defined above now have defined how features and targets are created. And data here is delivered to us according to some more parameters that we can define in this function from the workflow called get train validation test data. So we define a starting month, which is going to be the earliest time from your data set, and then you define the length of validation and test months that are going to correspond to the size of the validation and test data sets. And there's also an argument here where we can force a redownload, because this function is going to try to cache the data so you don't re-download the same exact data set twice, but for any reason, if you want to force it to re-download the data, you can by changing this to true. And now this does take a few seconds here. It may be about a minute or so, but it generally actually goes pretty quickly. The second time that you do this with the same parameters, it should be loading the saved file. That's going to be it's going to appear down here in this pane, like after we get done downloading. I guess one thing you could say here is that at a basic level, we function on 5-minute bars for this, and that is pretty much due to the fastest cadence that the Allora Forge topics run at is 5-minute cadence. Okay, so our data has been downloaded. You see the file pop here. So the next time we run it, it'll be faster using that cached data. First thing we could do is just visualize the time spans of our data sets. So just as we indicated, the earliest time point in the data is January 2023. And the validation and test sets both correspond to 3-month sections that are now in the most recent time with validation coming before test. Also, according to those parameters above, we've created a data set with real features in each row. And so if we want to visualize the features, this is what they look like, which are normalized historical candles before every trade, where here we have the dots are the open, high, low, and close of each candle, and the bars are the volume, and everything's been normalized. So the most recent price is always 1, and the most recent volume is always 1. And so this is kind of a basic way that you can now use more intelligent feature engineering to try to extract better features to make predictions better. But for the sake of this example, we're just going to use these raw features to try to get some performance out of our model. We can also visualize the target, which was created according to our 24-hour variable that we set. Here for this particular data point, the blue represents historical data that went into the input features, and the green represents the future that we don't know yet at time of prediction, and the red dot would be the value at the end of the 24-hour prediction window. And the thing we're predicting here is log return, so it's going to be the difference between now, which is represented at this point, and the future price at the red dot. So here we just call this, the next step is to now, using the data, is to create a hello world ML model. And so we're going to be using a light GBM regressor with just some basic parameters that I really pulled out of a hat. Gradient boosted machines still tend to dominate for this kind of data set, like whether it's on Kaggle or in finance. So it's not, even though it's fast and lightweight and it produces some results, it's actually something that could actually be pretty good with the right feature engineering and other parameters. So here we're just going to execute this. It's going to train on the training data. I put in some comments here for if you want to do like early stopping according to the evaluation, the validation data. This would be a way that you use the validation data to help pick like what would be the best model. But here we're just going to train it because it can be a very tricky problem, which hopefully will be the content of some future videos. But we're just going to train, and then this can also, I guess, take a few seconds, especially depending on how many estimators you're using. Here I'm using 2000, so on the CPU, on Colab, it can take a little while. Yes, training actually happens twice. That's the second time we train on both the training and validation data, simulating as if we had evaluated a bunch of models and picked the best one. Now we could retrain on all our data besides the test data. So here this should finish up in a second. So training has finished. The last step here was to produce test predictions, which now we have a built-in evaluation method with some key metrics, which are correlation and directional accuracy. We want to get these as high as possible. And in the future, we'll be building this out to have some more useful metrics for understanding the quality of our predictions. Assuming we like our new Hello World model, our next our next step is training again now on all the data, and then we run this, and this might take a little while again. After training the model, the predictions are going to be produced according to this function here. So the live features come from the workflow with this function that delivers the features in the same format that they were during training in the data sets above. So in our case, we didn't do anything to the features. We just feed it to our model and create predictions and return the predictions. But this predict file is completely customizable. So if I did some feature engineering, I could insert my feature engineering here. And if I wanted to combine predictions from several models into one, I could also average several models' predictions in here. This is really where I can make my, I can match my prediction, my live prediction to whatever I was doing in the analysis above, whatever I found worked the best. In my case, I didn't do any special feature engineering, and I'm just going to submit predictions from this one light GBM model. So I just keep things like this. Also to point out for the different data that you're looking for, this get live feature takes an argument for the ticker symbol, which for other topics you may need to change that. All right, so our model has been trained, the predict function is created, and the next cell gives us a place to just test to make sure this predict pickled file is loading and producing predictions, which it did. And finally, in the last cell, we can actually deploy our worker. This worker from the Allora SDK is going to by default deploy us to the new free topic, which is topic ID 69, which is the Bitcoin 24-hour prediction topic. So it's open to anyone. You don't have to get whitelisted for that. But if I wanted to indicate a different topic ID, I could do it right here. So one of the other topics right now is 64, for example, the 8-hour prediction. I could indicate that here. But for me, I just want to kind of get this going on the 24-hour Bitcoin. So I'm going to leave that as a default value. So I'm not going to set that parameter. And in this step for the mnemonic, if I don't have a wallet yet, if I don't know my mnemonic, I can just hit enter and a wallet will be generated for me automatically. And the information about the wallet is going to be saved to this hidden file that you can find on your disk. So let's see what happens here. So a worker node is actually something that kind of stays online all the time and submits predictions according to the submission windows that open periodically for the different topics. So you can see our most recent topic for our most recent submission for topic 69 went through successfully. So we can get some feedback about that here. And if you want to continue to submit predictions to the Forge competition, you got to leave this, leave the worker online and let it keep going. And in this case, I think every 5 minutes, it's going to submit another new submission. Some other topics are going to run more slowly, like every 2 hours, but just to keep in mind that this needs to be running in order for you to be submitting If you stop the notebook, it stops running. So it's really meant as like an instructive way to do this, and you can easily package this into a Python file and run it anywhere else. It's really up to you. So that's going to be the end of our tutorial. I hope everyone out there can start doing some cool feature engineering and coming up with some cool models, doing some neural network work, some transformer work would be really cool to see. And yeah, good luck and happy coding on the Forge. Thank you.